Hi everyone, it is great to be with you here today. We are going to discuss building your first iOS application with Xamarin for Visual Studio. Now in this webinar, we'll explore together how to use Xamarin for Visual Studio, and we'll see how we can create our first fully native iOS application. To do this, we'll need to look at and understand a typical Xamarin iOS project structure. We'll also touch on the MVC pattern in terms of designing our application structure, and we'll see how to use the Visual Designer to create a fully native UI for our application. And then finally, we'll round this off by deploying our application with the native Apple toolchain to a simulator and then also a real iOS device. But before we jump into content though, let me introduce myself. My name is Chris van Wyk, and I'm joining you all the way from Cape Town in South Africa. I'm one of the Xamarin University instructors. If you do not know what Xamarin University is, well, Xamarin University is the place to go for the most comprehensive and up-to-date Xamarin-focused training. Let me give you an idea of what to expect from XAMU. XAMU provides live classes with expert instructors guiding you from a typical Hello World application all the way to an offline-enabled mobile app, for example. As a XAMU student, you have access to one-on-one office hours to work individually with an instructor on your specific training goals. In addition to that, we have an amazing Xamarin community with a private forum just for Xamarin new students and instructors. Then finally, the opportunity to become a Xamarin certified mobile developer, which is quickly becoming a benchmark certification. If you would like to learn more or enroll in XAMU, please visit university.xamarin.com. Our main goal for today is to build and run a Xamarin iOS application. I want us to step back from that though and start with an overview of the process. Microsoft offers end-to-end tools for developers to create and publish mobile applications. And the Xamarin Development Platform lets you build native Android, iOS, Mac, and Windows applications all in C#. This is what developers usually talk about when they are discussing Xamarin. And that's actually a huge part of Xamarin, but Xamarin is a lot more than that. For example, we have Test Cloud. So Test Cloud, which is a UI testing solution, allows you to write outside-in tests and deploy them with your application to our collection of devices hosted in our testing center. The Xamarin tools enable you to build native applications written in C# for each platform. And with Hockey App, you can quickly deploy beta versions of your applications to your testers to ensure your application is amazing before releasing it to the public. And then, once your application is published, we have tools to monitor usage, track custom events, and receive crash reports. So today we're going to focus on creating and running a mobile application for iOS written in Xamarin iOS. And we'll look at how you build your UI, how we share code, for example, and how we can access services that is remote to your application. So let's see how we're going to do this. As I've mentioned earlier, we'll explore together Xamarin for Visual Studio. Now, doing so, we'll see how to create our first fully native iOS application. We'll look at a typical Xamarin iOS project structure, and we'll also explore the MVC pattern. We'll use the Visual Studio Visual Designer for iOS to create a fully native UI, and then finally, we'll deploy the application with the native Apple toolchain to a simulator as well as a real iOS device. As we work through the session's content, feel free to ask questions in the chat window. We have a couple of instructors and Xamarin mobile experts available to answer all your questions. So if you have something that's burning in terms of questions or something I've mentioned, feel free to use the chat window and say, hey guys, explain that again, or how can I do this or that? Also remember that all the sample application code for this session and documentation you need to get started will be made available for download. To make sure everyone has the same understanding on how Xamarin approaches mobile development, I want to quickly touch on the Xamarin development strategy. With Xamarin, you write a unique UI for each platform, but share your core business logic. This typically results in 70 to 80% of your code being shared, and this means that you have code that now can be reused for iOS, Android, and Windows applications. It also means that you will have 30 to 20% UI-specific code, which is core to the iOS framework and platform-specific features for iOS. Now, for me, personally, this is great. In this way, you get to reuse your business logic, keep features in parity, and still create native performant applications for each platform. Keep in mind, all of the code that you are writing, both UI and business logic, is done in C#. And if you are a .NET developer, there's a comprehensive runtime that gives you all of the great .NET features you're used to, including common .NET types and garbage collection. Xamarin offers exceptional performance on each platform. For iOS, your application is a fully compiled binary, offering all of the performance you'd expect of a native compiled application. Xamarin offers native performance, and with the language advantages of C# and the runtime advantages, it can even create applications that are faster than the applications written in the native languages. Here's a bigger picture of how all of this fit together. Now, please keep in mind that this is a simplistic view, so bear with me as we step through this. First, we need to have a look at the unmanaged world. At its core, iOS has a Unix-like kernel based on Darwin, which is a composition of code derived from NextStep, BSD, and other free software projects. On top of this, we have the Objective-C runtime and the exposed iOS APIs, which you will come to love as you create your applications. And then we have the managed world. So as part of your application, a runtime engine is deployed with your application, which will provide type checking, static reflection, interop, and garbage collection services to your application. This runtime includes a subset of the .NET Framework class libraries based on the shipped 4.5 assemblies from Microsoft. This includes features like link, tasks, XML, regex, I/O, and networking APIs. This runtime engine also includes the runtime binding definitions for all of the released iOS APIs. So this is our link from the managed world to the unmanaged world. And this is a rather important aspect, since it means your application is interacting with the native iOS APIs. Your binary or application is created via a cross-platform C# compiler that is fully compliant with the latest C# specifications. An optimizing native code compiler and linker is used to create the native code that Apple's tools will expect to work with. Now, you might be worried about API coverage. For instance, can you use all the features available to Swift developers, or can you also use the new iOS 10 features? And the answer to both of these two questions is a resounding yes. Xamarin has 100% API coverage, all accessible in C#. Xamarin also has a long history of making very timely updates when new versions of projects are launched. For iOS, Xamarin has achieved same-day releases every time since iOS 5. We do this by tracking Apple's developer preview, so our SDKs are ready to go when Apple launches their official updates. Today we're going to focus on handheld mobile devices, specifically phones and tablets. But keep in mind, Xamarin fully supports other iOS devices. You can create applications for the Apple Watch or the Apple TV. It's really up to your imagination in terms of what you can achieve here. One last thing I want to share with you before we jump into any code. Xamarin is now also completely open source. Because it is open source, you can download the source code, review the code to see how things work, and even add features to extend the platform. And if you want to contribute, Xamarin takes pull requests. Up to this point, we've really just covered some Xamarin iOS theory. You are, however, welcome to visit the Xamarin developer website to explore the inner workings of Xamarin iOS further. Let's change gears and look at writing code. When it comes to development, we have two IDE choices available to us. For Windows users, there is support for Visual Studio 2012 and above, including the free community edition of Visual Studio 2015. With Visual Studio 2015, you can install Xamarin right from the Visual Studio installer. Older versions, however, require you to run the Xamarin installer. Keep in mind that you still need a Mac with Mac OS and Xcode installed, plus the Xamarin tools to use as a build host. For Mac users, you can use the Visual Studio for Mac, which is a customized version of the open source mono-develop IDE. It looks and behaves very similar to Visual Studio, and it works with any Xamarin license, including the free starter edition. For both IDEs, we recommend you run on the stable Xamarin release channel and stay up to date to match new releases in the Apple toolchain. Keep in mind that Xamarin build tools are included in all editions of Visual Studio. Now, I've just mentioned that we can use a Windows PC with Visual Studio to compile our iOS applications. The problem is that we also need a Mac to connect to. So now you may be asking, why is this a requirement and why can't I do everything on my Windows machine? The answer to this is in Apple's licensing requirements. Apple licensing requires that we build the application on a Mac with the Apple SDK. That means we can't do everything on the Windows side and that you'll need a Mac to actually do the final compilation. Xamarin solves this problem through a service installed on a network-connected Mac known as the Xamarin Mac Agent. Visual Studio then connects to this process and delegates a portion of the build to this Mac, allowing us to compile with the native toolchain, then eventually launching the Apple-provided iOS simulators, or even deploying to a connected device. Now, to achieve all of this, you will need to install the Xamarin installer on your Mac. You'll also need to make sure that you have the latest version of XCode installed. Our wizard will then take you through all the steps to set up and enable access from your Windows PC to your Mac to ensure that this process works end to end. Visual Studio and the Xamarin tools provide everything you need to create and run an application. With Xamarin installed, Visual Studio will have project templates for universal applications to include iPhone and iPad type apps, Apple Watch applications, and even Apple TV applications. For Xamarin.iOS, Visual Studio also includes a designer tool to help you create your storyboard and zip-based UI layout. This designer supports features such as auto layout and size classes to make sure you are able to create the best looking applications for your users. Once your application is ready, you can run it on the XCode provided iOS simulators or even a connected physical device. The iOS simulator is particularly interesting with a Windows or from a Windows perspective because it's running on the Mac build host while you are able to interact with it remotely on your Windows machine. With the remote iOS simulator for Windows, testing and debugging iOS apps is entirely now possible within Visual Studio Enterprise on Windows. You no longer need to have a remote desktop session open to your Mac. The remote iOS simulator requires Visual Studio Enterprise licensing and is available as a separate download. So make sure to have your Visual Studio Enterprise installed with Xamarin and then install the actual simulator software. Now, to use the remote iOS simulator, you're going to need to make sure that your Visual Studio has at least connected once to your Mac just before starting the remote iOS. Then you're going to set your iOS application as the startup project, select a simulator from the drop-down configuration options, and launch your application. The simulator window toolbar includes a number of buttons to interact with the simulator. For example, you're able to simulate the home button on the device or lock the simulator. You can even save a screenshot of the simulator to disk, or even configure the keyboard and location of the sim. In addition to all of this, there's also a variety of simulator options available, such as rotation, shake, or invoking other statuses on the simulator itself. So this is a great feature, but you know what? What's even better is touch screen support. So most modern Windows computers have a touch screen, and the remote iOS simulator lets you touch the simulator window to test user interactions in your iOS application. And this is awesome. I mean, you can't even do this on your Mac. So this includes pinching, swiping, or multiple finger touch gestures as well. Things that previously could only be easily tested on a physical device. Even the Windows stylus is supported, and that support translates to Apple Pencil input on the simulator. So definitely something you want to try out. I want us to now look at the IDE experience. So let's jump into Visual Studio for Windows and then follow up by looking at the Visual Studio for Mac experience. And while I do this, you will get a good idea of the basic composition of a Xamarin iOS application. So we're basically going to create an application from a template, and then we'll look at the various files that gets created in this project and how you should think about it going forward. Right. I've got Visual Studio Enterprise Edition 2015 installed on my machine, and we are going to create our iOS application in it. This allows me to run the remote simulator, and we'll be able to step through all of the design time files created. Now, the first thing I'm going to do is create a new solution. So we're going to go File, New Project, and from here, the options available to me is either Android, cross-platform, iOS, or even tvOS. Now, we're going to select the iOS node, and from this node, in this selection, we'll go iPhone. And if I select the iPhone option, you'll notice that I now get a couple of templates to choose from. I can either choose gaming applications using frameworks such as Metal, OpenGL, SceneKit, or SpriteKit, but I can also create navigational style applications like master detail, page-based apps, single view applications, or tab-based applications. For this demo, I'm going to create a single view application, and I'll call this app demo 1, and we're going to drop it onto the desktop. Now, what's key here is that I do need a connection to my Mac build host, and this will show up with this icon turning green. So you'll notice here at the moment the agent is starting up. So we'll wait for that to start up, and then we'll be able to change some of the configuration for this project. The first thing I want to do is I want to change the actual targeted configuration. At the moment, it's going to point to iPhone, which is going to sort of try and deploy this application to a device. This device must be connected to my Mac. At the moment, I don't have a device connected there, so I'm going to select iPhone Simulator. As soon as you change it, you'll notice that we are going to choose, or be able to choose, one of the simulators available to us. Right, with that out of the way, we can now look at the items created inside the template. The first item is this Getting Started page. So this is your entry point into knowledge around iOS dev, and you're welcome to follow this. It'll take you to developer.xamarin.com, and there's a treasure trove of information there. Docs is amazing. The documentation team is doing stellar work, so please visit this site for more info. I'm going to close this down though and talk about what got created inside my solution. The first thing I want to point out is that we have a standard.NET solution file. So it's an MS Build-based project, which can be loaded into either Visual Studio or Visual Studio for Mac without any changes made to the solution. There will be a CS project file, so there will be a result set compiled, so there will be some output, either an executable or a library. In this case, it'll be a full-blown native iOS application. The next item I want to point out is references. So references is where I add in compile and runtime assemblies that my application may be using. And you can add new assemblies in the stock standard, right-click, add references mechanism, or even you can add NuGet packages to your project. Right, so all of that is available to us. The main item to point out here is Xamarin.iOS. This is the library that contains all the API definitions that we will be using inside our iOS applications. The next set of items I want to point out is asset catalogs, as well as resources. These two options allow me to add additional assets needed at runtime, such as images or icons for my application. I can also add in fonts and soundbites if need be. Now, files in this resources folder need to be set with a build action of bundle resource. This will just make sure that those files end up in your application. You'll notice though that currently we have a launch screen inside this resource file. This is going to be the initial page that gets displayed, or scene that gets displayed in our application. So basically, not my interactable section of my application, but the splash screen. I think that's going to be the better sort of description there. You'll notice that we have a zip file here, but we also have a storyboard down here. And I'll talk more about the storyboard a little bit later. The next file I want to point out is the application delegate.cs class file. Let's close the properties or the toolbox just for a second and talk about this file. Application delegate.cs is responsible for creating the main window and listening to operating system events. That's kind of interesting. What happens here is that we're going to say, you know what, OS, this application will respond to messages from you. So I'm going to delegate a class that will deal with it. It's part of the MVC pattern that Apple implements, and we'll talk more about delegation and protocols a little bit later. For now though, notice that this class file has things like a window. It also has methods like finished launching and did enter background, for example. So we'll know when the application launched or the application is going into the background. So it's no longer the first application the user sees. The next set of files I want to talk about is this guy called entitlements plist and information plist. Now, iOS has this concept of property list files to store application metadata as key and value pairs. The entitlements plist file lists external Apple services that your application wants to interact with. Things like in-app purchases or health kit and push notification, for example. The second file, information plist, identifies metadata about your application. So you can see in here we have demo, the application name, the identifier of this application, build numbers, etc. It also has things like the launch screen or the main UI interface. That main storyboard gets listed here. Both IDEs will provide you with a GUI where you can change properties in these two files. And then we get to main.cs. So main.cs is our entry point into our application. It contains the main entry point, and it's typical to standard.NET applications. You can see static void main. You must have seen this before in a console application, for example. This class file starts up the iOS UI framework or UI kit and identifies the Apple or the application delegate that we have, which will in turn bring up the initial screen for the application. So you can see how this now kind of works. It says, you know what, UI application, this is my application delegate. App delegate points to that application delegate CS file, and it now will set up our initial window. The question is, how does this thing know which screen to use? Well, it's going to look at your information plist file and says, oh, you know what, there's a main interface, which is going to be main storyboard, and it will contain that information. It will contain that initial screen that we need to see when the application runs. Right, so main CS starts that up, which then brings me to my main storyboard. So this main storyboard is going to be editable, and initially, since this is a single view application, I will be able to only see one scene. So this does take a bit of time to launch and get ready. So I'm just going to pin my toolbox, and then we'll be able to edit this scene. Currently, this may look a little bit odd. We don't have a device that looks like a rectangle square like this. So what we'll do is we'll change that layout and we'll just switch it to, let's say, iPhone 5S. So now I've got a phone-sized view, and I can maybe drop a label onto this. And I'll do that, and I'll explain the designer a lot more in detail a little bit later. But for now, let's just modify this guy, that label. And I'm going to change my text. So instead of it just reading label, I'll say welcome, and with an exclamation mark, and we should be good to go. And you'll notice that it wraps the text, so I should be able to just size that label a little bit more and then drop it there. Okay, with this in place, my application is nearly ready to run. There's one more thing I need to do though. I need to set up a class file that will allow me to interact with this view. So you'll notice that we have this last viewController.cs class file, and this guy is going to allow me to access that declaratively defined UI component that gets loaded by the operating system, and I'll be able to interact with it. So you'll notice that my viewController, subclass is UI viewController, again, points to that MVC setup that we have, and we'll talk more about that later. Also notice that my constructor has a pointer. That pointer points to the memory address of this view that has been generated and my viewController. So I'll be able to access it and start interacting with that Objective-C world object that's running in the operating system in my application. Also notice that I have overrides inside this class. So things to view did load or did receive memory warning. So again, something will be sending messages to this class, and I'll be able to, or I will need to be able to interact with it. One thing I also want to point out is that you'll notice there's a disclosure indicator down here, and there's a viewController designer.cs class file. So this is going to give me access to the visual representation of my application in terms of this scene. So how does this file get used? Well, let's go back to that main storyboard. This viewController, notice that we have specified a class. So what we're telling the operating system is that there will be a class file, there will be an object that you can send messages to when something happens on this view, and it's going to be this viewController class, that CS class file that we have there. Right, so there's a little bit more to this. For instance, you'll notice there's a bit of registration to say to the operating system that this is the class file to use. And the same thing happens here with the application delegate. So this is our way to say, you know what, Objective-C, when you need something from C#, this managed world, these will be the classes that you are going to point to. Right, so these will be the objects. So it's literally allowing the unmanaged world to invoke code on the managed world of things. Right. So let's stop here and change gears to MVC, the design pattern. We're going to switch back to the slides, and then we'll come back to code a little bit later in the session. As you now have seen, the generated template application is pretty straightforward in terms of the files that gets created. And there's a lot of commonality between different templates, for example. iOS development is daunting for new developers. Generally, you have to learn a new language, a new framework, and Apple's recommended architectural patterns. One of these we've already solved. All of our code have so far been in C#, so that's already a big win for us. We don't need to learn a new language. And as far as the frameworks go, we should be able to pick these up as we need them in our application. So the bigger problem when starting with iOS development, at least with Xamarin.iOS, is the question of how do I now go about structuring my application? So if you think to the template application from earlier, it seems as if I have a code behind file directly related to a design time view. But how does this really work? How should I think about separation of concern, for example? I want to talk about the MVC, or the Model View Controller design pattern, and as it is implemented by Apple. Over the next couple of slides, we're going to look at this pattern, see the ins and outs, and we'll then look at how this gets applied in an application. The Model View Controller pattern has been around for some time now, and I'm pretty sure it will not disappear anytime soon. It was first introduced into Smalltalk at the Xerox Palo Alto Research Center, and this was around about in the 70s, and as such, it's these days seen as a mature design pattern. Since then, the pattern has evolved, and today we see several variants such as MVP, so the Model View Presenter pattern, or MVVM, Model View View Model. These are all patterns we as .NET developers have run into at some point, so it should be easy for us to grasp the concepts that the MVC wants to sort of portray. The primary focus of these patterns are ultimately to allow you to design a decoupled and layered system. So in that sense, it should be not that difficult to use the pattern. However, Apple's take on MVC is a bit different than some, and you will frequently run into terminology such as protocols and delegates which are thrown into the mix. Since the entire iOS API is built around these patterns and concepts, it makes sense to dig into this a bit further. So let's start by talking about the model. When you hear the word model, you generally speaking think about the data that you will be working with in your application. But this data is really arbitrary. It's more than just domain objects or internal data. It can also be code to access a database or communicate with a web service. It will be code defined by you as the developer, some of which will be reusable and other parts very domain specific. Ultimately, this layer can be seen as what your application is, and for the most part, the iOS APIs is not concerned with this part of MVC. Views represent the UI the user sees, and you should not see any business logic in this layer. The view should be seen as a generic object. For example, a button is a button on any screen, irrespective of where you place it. The user taps on it and something will happen. Therefore, the main concern of this layer is to present visuals and allows for user interaction. In terms of iOS, the base class for a view is UIView, and you will also notice that this class implements the iDisposable pattern from a C# memory management perspective. Views can be created declaratively through storyboards, i.e. multiple screens, or zip files, single screens, or even imperatively using code. We'll stick to the Visual Designer for today's session. But let's go back to MVC. The interesting thing here is that we say the view does not implement logic. So this now raises a question: how is user interaction dealt with? Ultimately, tapping on a button could action a decision to fetch data from either a remote web service or a local data store. Where does this logic reside? The interaction between the model and the view is always done through a controller. So let us define this as follows. The controller is managing the process of how your UI is presented to the user, in effect, the UI logic. So from our perspective for today, controllers in iOS are always UI view controllers. If we need to look at the class implementation, it's a UI view controller. And so far, this pattern seems pretty straightforward. The catch here is communication between these two items though. So a controller can always talk directly to its model. And to display data to the view, the controller can always talk directly to its view via something called an outlet. This is something that we'll spend a little bit more time on later today. So let's take this generic concept of a view a little bit further. Being generic requires that the view communicate in a blind but structured way. So this means that we need to have user interaction, and this needs to happen in a way that can be managed in a loosely coupled fashion. So the view does this via actions. The view sends actions to the controller, and you will see that we'll implement something called an action to achieve this. And again, we'll look at that as soon as we hit code. Sometimes the view also needs to synchronize with this controller. For example, did the view load or did the view appear? To manage this, the controller will set itself as the view's delegate. And this is where the concepts of delegates and protocols kicks in. For simplicity's sake, see a delegate as a class that conforms to an interface definition, but other than a .NET interface, allows for optional methods. So this generic view can now rely on the controller for synchronization, for example. Sufficient to say that views do not own the data they display. So if needed, they have a protocol to acquire it. And this means the controller generally ends up being the data source and not the model for your application as well. So for example, how many rows needs to be displayed, or which row did the user tap on if we have a table view? Now, as I've mentioned, the model is UI independent. If the model has information to update, it uses a broadcasting mechanism. We typically see notifications or key value observers being used in Objective-C and Swift. From a .NET perspective, we typically rely on event notification or iNotify property changed. However, nothing prohibits you from using KVOs if need be. So the most important point I want to make here is that there's no communication between the view and the model. There's never going to be interaction there. And communication from the controller to the model and from the controller to the view is one way. So there's some kind of notification that will happen for the model to interact with the controller, as well as the view to interact with the controller. The controller and view will always be present in an iOS application, as will be the case for the model. What we find is that the view and controller conceptually ends up in our UI layer, whereas the model is typically or should be something shareable across multiple views and controllers. Something that you may notice here is the possibility of the model bleeding into the view controller. For example, accessing a web service directly from controller code. This approach leads into scenarios where MVC turns from being model view controller into massive view controller. At first, this may not be a problem, but as soon as your application grows, it will result in technical debt, pain, and heartache. So we need to really get this right at the beginning and make sure our application conforms to this. With this in place, your development should be a pleasure. Let's jump into Visual Studio for Mac to look at a demo where we're going to have a look at the MVC pattern as it is implemented in a UI table view controller. I find the UI table view controller the best example to show this with. So let's open up demo 2 and have a quick look. We'll not write any code in this demo. We'll just step through the actual code that's in here and then see the application as it runs. In terms of the solution structure, you'll see that it matches what we see in Visual Studio on Windows, so nothing different here to worry about. The only difference is the actual first scene. It's no longer a single view, empty canvas, but a table view controller. And you'll see my backing class, table view controller, subclass is UI table view controller. Our model is going to be this array of sessions, and my view obviously is going to be a view that we have defined. Now, the controller is going to pick up this information and become the data source for this view. So to do this, we need to quickly look at the implementation of the UI table view controller. You'll notice that it has defined a couple of interfaces, but the most important here is the UI table view data source, that first protocol, then the UI table view delegate, which is the delegation of and messaging to respond to user interaction from the view. So that's what we'll focus on. But also notice we have disposable as well as UI scroll view delegate. So this table view is actually quite complex in terms of what it can do. So let's have a quick look at the methods that we've overrode. The first one that has been overridden is the rows in section, and then we have get cell. So both of these two methods deal with synchronization of the view. Remember, your view is simple. It's literally dumb. It only presents information, and it's quite generic. So for it to do its thing, it needs to know how many rows we need to display, so sessions.length, and it needs to know what to display. So for each of our cells, we'll grab the information and then display that. When a user taps on a row, we need to be able to respond to that tap. The view does not do it, the controller does it. So you'll see we'll implement that delegate method, row selected, and in here we'll just display an alert to the user. So let's run this and see what it looks like in our simulator. Right, so here's our application up and running. I can tap on rows and I can see that alert showing up. So the flow is from model, where the controller picks up that information. So it actually goes and requests it, right? It then sets up the view with rows in section, get cell, and then when there's a notification of a user event, the controller picks up. It's the delegate for this view, so it will then display that image or that alert. Right, let's jump back to our slides and continue with our content. As interesting as the previous information may be, it's not going to win me customers if the UI of my application is not appealing. So again, let's change gears and look at the creation of UI. Xamarin.iOS UI is built from the same objects as you would find when building an application in Xcode with Objective-C or Swift. The same Apple controls and layout panels are wrapped and exposed as C# classes by Xamarin. So everything that I choose will end up being a native control on my application. This means that your UI will always be native and have the same performance as an Xcode created application. Remember, your users chose iOS as his or her preferred mobile platform, even if they potentially cannot tell the difference between an Apple or an Android device. This means they will expect the same iOS idioms like look and feel and performance from your application as other iOS applications have. And if you can provide this, your users will love you for it. There are three ways for us to define UI. We can either use code and declare the UI imperatively, or we can use the designer available in Visual Studio either for Visual Studio on Windows or on the Mac, or we can switch to Interface Builder from Xcode. The designer file formats you potentially will be working with is storyboards and zip files. Storyboards let you design all the screens and relationships in your application, whereas zip files define a single screen at a time. Let's have a look at a more complete application and add a couple of controls via the designer, just to get a feel for this and see what we can create from an application perspective. For this demo, we're going to again use Visual Studio for Mac, and I have an already created application called My Weather. My Weather allows me to go and fetch weather for a specific location. So let me run the application so you can see what it looks like and the behavior that we have.
(27°C scattered clouds).
So what you'll notice here is that we use the text-to-speech engine after we fetch the data and we return that information. I get the actual temperature for a location and then a 5-interval forecast. The town that I use as a sample is called Kakamas. It is a very small town in South Africa, very hot over the Christmas period, 47 degrees the one day. So I thought it apt to add it in as the default location in this application. Now, what do we need to do? I would like for the user to be able to modify the location. So I'm going to add in a UI text field into this actual view plus a refresh button, because at this point the user cannot refresh the data. It needs to restart the application, which isn't ideal. So we're going to fix that up. Alright, so once the storyboard has loaded, we are able to interact with this design. You'll see I've got a number of items that I've placed here, all of which have specific layout being set up with constraints to indicate where these elements should be. Now, what we are going to do is search for a button. So that will be the first item that I'll place onto this view, and I'm going to modify the button a little bit. I want to make sure that I use a custom button. I want to display an image and I do not want to display any text. Now, since I have resources in my application on the left hand side already included, these will show up as images that I can add into the button. So I'll go to this image download and select the refresh PNG that's available there. All right, so if I can just get to that refresh, there you go. Okay, so you can see there's the refresh. There's one more thing I want to do. I want to set the actual size of this button quickly, just to make sure it's a decent size for someone to interact with. And then I'm going to make sure that I sort of anchor it at this position. I always want to have it at this right-hand side top. Now to do this, I could set and rely on these coordinates, but that's not going to be ideal. If the orientation change, this will be literally absolute. So we are going to make use of auto layout. I'm going to be able to use these, let's say, handlebars that's available on the actual object after I've tapped on it a second time. So by default, I can size it via these bubbles, but otherwise I can set it up like this. Now there's a couple of things that I'm going to do just to make sure this object is fully constrained. So once it turns blue, that's where I'm going to let it be on the actual UI. Now I can go and modify these constraints if I need to. So I can go and set, well, I don't want that 15-point offset, I want it to be 10, and then I can check the update with the toolbar. So the toolbar at the top of the designer gives me interaction on the storyboard in terms of the size of the view, the orientation of the actual layout, constraint interaction, and then just normal zooming in and out to see what I'm doing closer by onto the view. As you guys have noticed, I've got the toolbox, which allows me to go and search for items. So I'll be able to go and search for a text field, and then once I have it, I'll use the property panel to go and update whatever is placed here. There's one more item, and that's the document outline here. So the document outline will give me access to everything that's been created. Sometimes this can be quite handy as well. But let's deal with this text field. I want it to size itself based on where the button is located. So a constraint is going to be the best option to do so. First off, I want to align it vertically to that button. So I'll do that. I'm also going to set it to the leading edge of the view and to the trailing and leading edge of the actual button. And then this constant I want to change. I want to change this to about 5 points. So that text field should now sort of stretch out. And if the orientation were to change, it will sort of keep that in mind and readjust itself. So that's pretty cool. There's my text field. I now need to be able to access these guys from my code bound. So the first thing I'll do is name the text field. Why am I naming this? Well, as soon as I name this text field, it's going to create an outlet. So if you think back to our MVC section, outlets is how I'll be able to access items from a view's perspective. So the controller can now access it. And you'll notice that my view controller has the designer CS class file, which literally matches what we see. So there's the outlet that I've just created. The second item that I need to name is my weather button. And I'm going to call this get weather button. Okay, so get weather button is also going to create an outlet. If I scroll down, there you go, there's that outlet. But that's all fine. How do I interact with events from these controls? We have a standard .NET way of doing so. If I were to go to my view controller, I would be able, inside view.load, when everything is available to me, do something like this. That get weather button, it's now available, and it has a touch up inside event. So let's see, touch up inside, there you go, and I'll be able to assign a normal .NET type delegate to this. Alternatively, I can rely on the messaging mechanism. So the view will send a message to its controller, and we enable it by setting up an event from the designer on that actual button. So I go to events, I'll be able to go and search for touch up inside and say get weather button touch up. And as soon as I do this, something interesting happens. You'll notice that I now need to add a handler. And this handler is a partial method, right? And that partial method's counterpart is inside the actual designer class file as an action. Right, so the message will be sent to this class, will respond to that signature, but in actual fact will execute the C# code. So jumping back to my view controller, I'll implement this code, and what I'm going to do is move this up into this region. I want to be able to resign first responder status. So the text field, as soon as I start editing it, it's going to display the keyboard. So I want, as soon as I tap on it, to dismiss the keyboard. Now you may be asking me, where do I go and fetch data? Well, fetching data is going to be done in the following way. I've implemented MVM Lite in this controller, so I'm using its binding infrastructure to bind controls to certain actions. So in this case of the weather button, it's going to bind to the get weather command on my view model. So my view model, as I've mentioned earlier, is now my model for my data in this application. So I still have the MVC pattern, but my model is the view model. So definitely have a look at this. And this is based on code from Laurent Bignot's Evolve 2016 session that I had. So please, I'll have a look at it. I will add the link to it in the material for today's class. Now, my text field also needs to be bound, so I'll add that code back in there, and then I need to enable a bit of interaction. Now, what I want to do is I want to allow the user to also tap on a view and the view itself, so in here, to also dismiss the keyboard if it gets presented. So to do this, I will include this method, which is going to add a tap gesture recognizer, and it's also going to fire off that same code, the resign responder code that we had. Right, so with this in place, we should be good to go, and the application should behave as expected. So let's run and check that out.
(27°C scattered clouds).
Right, so let's see what's happening in Cape Town. So I'll go and type in Cape Town. Cape Town, and it's going to fetch the data.
19°C clear sky.
And you can see that panned out as expected. The keyboard disappeared, and I'm really happy about this application and the way it responds. Now, there's a lot of stuff in here that you probably want to check out. For instance, you'll notice that we make use of the humanizer package. So to properly title case, for example, elements that get set in a PCL. You'll also notice that in terms of other packages, we use MVM Lite, as I've mentioned. We deserialize JSON, so we have a web service. We also have connectivity plugins, so I check for connectivity and make sure that is available before I request info. We set settings, we have text-to-speech, so explore this code. There's a lot of interesting things in here, I think, that may be quite useful for you. We also have a bit of error handling, so we pop up certain dialogues and display certain alerts to the user when there is an error. Our last step here is to deploy this application to a device. It's the final mile that we need to cover here. So we're going to change our configuration from iPhone 7 simulator to physical device. I'm going to run and deploy this application to my device, and then I'm going to use Reflector to reflect the actual UI, and we'll see what this looks like on the device. So let's get this up and running. I'll deploy to the device.
27°C scattered clouds.
So you can hear that was the actual device responding with a result. So let's mirror this. There's my UI. I'll be able to go and change the location, change that to Cape Town. It's currently set to Kakamas. So I'll change that to Cape Town, tap on refresh, and we'll get a result.
19°C clear sky.
So you can see that actually mirrored. So this is for me the ultimate, being able to take an application and getting it on a device. So let's wrap up this session and let's jump back into our slide deck. I hope this gave you a good idea in terms of what we can do. And you know what, there's so much more that can be created. Just need to think about all the apps out there on the iOS App Store. If you want to get started with Xamarin today, it's completely free, so there's nothing that's going to hold you back. And it's available at www.xamarin.com. So visit that download link and go download the tools. You can use the community edition of Visual Studio. You can get this for free, so do it. Should you want to explore Xamarin University further, you're always welcome to take the Xamarin University free self-guided courses. These cover the core Xamarin concepts. And also keep in mind that these classes also count towards certification, which means you do not need to retake them should you sign up for full subscription. Alternatively, dive right into it and get a full Xamarin University subscription and become a Xamarin certified mobile developer. And with that, thank you very much for your time. It has been a pleasure. Remember, your only limitation is imagination. If you can imagine it, you can create it. You're welcome to ping me via Twitter or send me an email via my email address. Please feel free to use those communication lines. If you have any questions still left, feel free to ask. We still have a couple of people online. XAMU professors are standing by to answer any questions, as well as our mobile experts. If you want to download the code from today's session, you're welcome to do so. Use the link here on the slide, and it's going to give you access to all the code that we've looked at. My name is Chris van Wyk. Until next time, take care and goodbye.